angle relationships. Yesterday we talked about angle measure. Today we're going to talk about angle relationships. And lots of terminology, lots of vocabulary today that you've got to know. You've got to know it really well. And the first one is adjacent angles. Okay? These are two angles that lie in the same plane, have a common vertex and a common side, but no common interior points. Okay? They're neighbors. Like Mrs. Turner and myself, we are neighbors. Our classrooms are adjacent to each other. The only thing that we share is this wall in between. Her classroom doesn't bleed over into mine. Mine doesn't fall over into hers. Okay? We have our own space. We're good neighbors with each other. Okay? So that's what adjacent angles are. It's two angles who share a common vertex and a common side or a common ray, and that's it. Okay, so angle 1 and angle 2 are adjacent angles. Another example here, this angle 1 and angle 2, they share a vertex and they share a side, and that's it. They're right next to each other. They're neighbors. Now, these are not neighbors, okay? If we look at this angle ABC, and then we look at this angle 3, they overlap each other, okay? They're not good neighbors. They're getting into each other's business, all right? So, these are not adjacent. These don't even have anything in common. Here, we got this angle 3 here, and we got this angle ABC here. They're not neighbors at all, okay? They're feuding neighbors. They don't even talk, all right? So, these are adjacent angles right here, okay? All right. Now, next one, important term. We talk about this all the time. A linear pair. It is a pair of adjacent angles whose non-common sides are opposite rays. So they're adjacent, they share a vertex, and they share a side, but then the side they don't share are opposite rays, which means they form a straight line. Hence, linear pair, okay? So together, they form a line. Okay, a linear pair, they're adjacent. Together, their non-common sides are opposite rays, which means they form a straight line. These are not a linear pair. If we look at ADB, which is this angle here, and we look at ABC, which is this angle here, they're adjacent, yes, because they share the vertex and the side, but the side they don't share does not make a straight line, so they are not a linear pair. They're just adjacent, okay? All right, we're going to talk more about some properties of linear pairs in just a minute. Then we have vertical angles. Now, vertical angles are non-adjacent, okay? The only thing that they share is a point, and they are created by intersecting lines. So if you have two lines that intersect, okay, your vertical angles are basically opposite each other. They only share a point. They make V's with each other. So like this angle 1 here and this angle 2 here, the only thing they share here is this point, and they're created by two intersecting lines. Those are vertical angles. Another pair would be angle 3 and angle 4. Those are vertical angles, okay? They make V's with each other. They're created by two lines. And so, like if I cross my arms, this one and this one are vertical, or this one and this one are vertical, okay? These are not vertical angles. And the reason they're not is because this line going horizontally is a straight line. But then you have these two random rays, okay? And so their angles are not created by two intersecting lines. So those are not vertical angles. Okay, and we're going to talk about another property of vertical angles here in just a minute. So, looking at this diagram here, it says name two obtuse vertical angles. Okay, two obtuse vertical angles. What do you think, Lauren? YZT is 50 degrees, so that's not obtuse. What does it mean to be obtuse?
YZT.
Y?
Wait, no, I meant VCT. I said Y instead.
Oh, okay. VZ. Okay, VZT is obtuse, but it.
Y.
Oh, that's fine. That's fine. VZT is obtuse, but it doesn't have another vertical angle. They have to be created by two lines that intersect, David. Okay, so VZX, this angle here, and what's its vertical angle? YZW. See how we've got a line here, and we've got a line here, and those two angles are created by two lines that intersect. So these would be our obtuse vertical angles, okay? So, angle VZX and angle YZW. Okay? My acute vertical angles would be these two 65-degree angles, okay? That would be acute vertical angles. All right, using the same picture, There's lots of different answers for this next one. We'll name a couple. Name a pair of adjacent angles. Name a pair of adjacent angles. Shaylin.
YZT and
YZT.
oh yeah. That B looks like a pie too, but YZT
YZT, okay.
and WTZ.
WZT. Yeah, WZT. Yeah, I know when I sometimes my letters get all mixed up with me. Okay, so angle YZT and angle WZT. Okay, let's name another pair. One more. What do you think, Brennan? YZT and XZT. Okay, good. Angle YZT. So we use that same angle, but then we use this bigger one, didn't we? Okay, and XZT. Okay, good. There's lots of different pairs of adjacent angles. Okay, now we talked about what vertical angles were. Vertical angles are congruent. Okay, so if you have the two lines intersect to create the vertical angles, then you know that vertical angles are congruent. So angle 1 is congruent to angle 2. And 3 and 4 are also vertical. So they are going to be congruent as well. So angle 3 is congruent to angle 4. You need to memorize that. You need to know what vertical angles are, and you need to know that they're congruent. Okay? All right. Now, on this next one, it says the sum of the measures of a linear pair is 180. Well, that kind of makes sense, right? If we have these two angles that together make a straight line, their sum is going to be 180 if you add those two angles together. We did some problems like that yesterday, didn't we? Okay, so the measure of angle 5 plus the measure of angle 6 is going to be equal to 180. Okay, so my vertical angles are congruent, and the angles of my linear pair add up to be 180. All right, here's some more vocabulary that you need to be familiar with. And some of this you might have had earlier, hopefully you might know it. Complementary angles. Those are two angles whose measures have a sum of 90 degrees. Okay? So if two angles add together equal 90, they're said to be complementary. Now, this angle 1 and angle 2, these are adjacent angles. And we see that together they form a right angle. So they're going to be complementary, right? Because it's right angle symbol. So the measure of angle 1 plus the measure of angle 2 is 90. So that makes them complementary. Here's another pair of angles. These are just two random angles. One of them's 30 degrees, one of them's 60 degrees. But their sum is 90, so that makes them complementary. So any two angles that add together to equal 90. Then we have supplementary angles. Supplementary angles are add together to equal 180. Your linear pair adds up to equal 180, so it's always going to be considered supplementary. You could have just two random angles, a 60-degree angle and a 120-degree angle. If they add up to be 180, then they are said to be supplementary. Okay? So supplementary adds up to be 180. Complementary adds up to be 90. You need to know that. Okay? All right. Here's a question. Find the measure of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. Okay, so we have two angles that are complementary. What does it mean to be complementary? They equal 90. So we have one angle plus we have another, and together they equal 90, right? Then it says that the larger angle is 12 more than twice the smaller. Do we know what the smaller measures? X. We're just going to let it be X. So then the larger angle is 12 more than twice that. 2x plus 12. 12 more than twice the smaller, okay? All right, so we add them together, set them equal to 90, and we'll figure out what one of them is, and then we can go and find the other. So we have 3x plus 12 is 90. Subtract 12 from both sides. Divide both sides by 3. And x ends up being 26, right? And so that is the smaller angle, right? Now, there's one of two things you could do here. We know they're complementary, so if one of the angles is 26, what are we going to do to find the other one? 90 minus 26. Okay, and so 90 minus 26 is going to be 64. Is that right? The other thing we could do is go and plug in, couldn't we? And do 2 times 26 plus 12. Either way, we'll give you that answer. Okay? So my two angles are 26 and 64. All right, there's another vocabulary word. Perpendicular. Those are lines that form four right angles. Okay? This is the symbol that we use for perpendicular. It looks like this. Okay? This little symbol right here. If I want to state that two lines are perpendicular, I would do something like this. WY is perpendicular to XZ. So then this picture should pop in your mind, or you would draw this picture. Okay? They don't share a point, so they don't intersect at any of these points. They intersect at their own point. All right? But if you were told this, and let's say that this right here was angle 1, if you were told that WY was perpendicular to XZ, then you could immediately say that angle 1 was a right angle. Okay? Because that's what it means to be perpendicular. Okay? Is that it forms right angles. All right. So, we want to find X and Y so that line BE and line AD are perpendicular. All right. So if these two lines are going to be perpendicular, what are they going to form? Right angles, right? And right angles measure 90 degrees. So what relationship are these two adjacent angles going to have in order for these to be perpendicular? They have to add up to equal 90. Okay, so that's what we're going to do. We're going to do 6x minus 4 plus 3x minus 5 equals 90. So that gives me 9x minus 9 equals 90. Add 9 to both sides. And so x is 11. Okay? So if x is 11, we'll get a right angle here. What's going to have to be true about this angle here, this 12y minus 10? What's it going to have to be equal to? It's going to have to be equal to 90. So 12y minus 10 has to be equal to 90. Add 10 to both sides. 12y equals 100. Divide both sides by 12. And if I reduce that, I can reduce it by 4, which is 24 thirds. That's 8 1/3. So x is going to have to be 11, and y is going to have to be 8 1/3. If that happens, I have perpendicular lines that form four right angles. Okay? All right. Before I go into this next one, I want you to look at this guy right here. Okay? We're not going to work it out, but we're just going to talk about it. Okay? I have two lines that intersect, right? And I want to find out what x and y are. Okay? What do I have here? Let's create it. I don't know this perpendicular. There's not a little right angles. What's up? Okay. So, which ones are you talking about? These two?
Yeah.
Okay. See how they form a straight line together? They are supplementary, so they add together to 180. But I have a problem. One of them has an x and one of them has a y, right? Okay, what else do I have? I've got vertical angles, don't I? So my vertical angles are equal. So I can set these two equal to each other to find y, correct? Once I know y, I can plug in and get a value here, can't I? And then I can take this value plus this, and it's going to equal 180. 180, okay? All right. All right, that's number 22 on your phone, okay? All right, now, last little set of problems here. You got the second category, okay? Think about these definitions that I gave you. Determine whether each statement can be assumed from the figure below. Okay, it says that LPM and MPO are adjacent angles. LPM and MPO are adjacent angles. So LPM and MPO, are those adjacent? What does it mean to be adjacent?
Do they only share like a wall?
Share a wall, a vertex, and an array. Do they share anything more than a vertex and array? No, so they are adjacent, aren't they? Go back to that definition. Okay, so my answer would be yes. They share only a vertex and array. Okay. All right, here's the next one. OPQ, and LPM. Okay? OPQ and LPM are complementary. What does it mean to be complementary? They add together to equal 90. What do I know about these two? They're congruent, right? We don't know their measures. All we know is that they're the same.
Well, they're, yeah, because LPQ is a straight line, so
But we're talking about these two. These two. Yeah, look at the letters, yeah. We're talking about these two right here. And We know that they're congruent, but we don't know that necessarily that they're both 45, right? If we knew they were both 45, then we could say that, but we don't know that. So my answer here would be no, and you could just put, there is no indication of their measure. Okay, last one. LPQ and QPO are a linear pair. LPQ and QPO are a linear pair. Yes, they are. Okay, what makes them a linear pair? Okay, they're adjacent, right? And what else has to happen? They're non-common sides, opposite rays, right? Okay, so yes, they are adjacent and they're non-common sides are opposite rays. Okay? Go back to the definition. Okay, that will help you determine one way or the other. Okay? All right, any questions? Okay, your assignment, page 51, 8 through 42 even, 49, 50, 62, and 63.